welcome back everyone. Second round of talks here at the DevDays Europe. And I'm your host, Florian Rapper, but I'm not alone. We have an awesome speaker coming up here, Daniil Doronkin. Hi, how are you doing?
Hi, I'm good. How about you?
I'm also fine. Thanks a lot. So you brought for us a really nice talk, a journey through the microservices data sharing. What is awaiting us in your talk?
Well, I hope you enjoyed. Here, I just want to reflect on my personal experience, how I work with these challenges when you're switching from monolith to the microservices. It's always a question about data. How do you exchange it? And in this talk, I try to wrap up my experience and what I learned from the past.
Awesome.
Hope it's going to be also useful for audience today.
Awesome, great. Yeah, this is also one of the things I've had to learn the hard way. I mean, going back, let's say 10 years already. I mean, if you construct a microservice solution from scratch, it's always the case. So what are you doing with data sharing and how self-contained should be your systems? And I think therefore, hearing from your experience, especially at booking.com, I think it will be highly appreciated by everyone. So therefore, I want to give you the stage, have fun, and thanks already.
Yep, thank you so much. Thank you for introduction. And such a nice way to start a working week, yes, with such great of event. And another good way to start your day is have some controversial topic about the monolith versus microservices. I think people argue a lot about whether of consistency should it be strong or we need to switch to eventual one. What kind of communications can we use, synchronous and asynchronous, and why? And finally, should we give up on the monolith simplicity in terms of microservices independence level? Those are good questions. In my case, as I said before, it was always how to evolve the communication layer between services when we're switching from monolith to the microservice, because now it's getting more complicated. So today I want to discuss it with you. And my name is Daniil. I'm a software engineer who was born in Kazakhstan many years ago, but last 4 years I'm living in the Netherlands and currently working for booking.com. I work mostly with the distributed systems, and I find it really excited. And it's always new about that. You can learn a lot, but still have a huge amount of things ahead, which you have to cover. And stay tuned, which is, I think, great. And apart from that, I'm also a Tech Talks fan, both as attendee and presenter. After this talk, I'm hope to join a couple of sessions and hear something from other speakers here as well. Before we dive into the details, I want to say that I don't want to cover monolith versus microservices and pros and cons here. Also, how to split the monolith into the number of separate services. And we don't cover distributed transactions and sagas. All of that topics are great and deserve the separate talks. And some of them already well covered. So instead, I want to focus more on data sharing techniques. How can we exchange data across subdomains? What kind of communications we'd better apply, synchronous and asynchronous, and why? And talk about the trade-offs, because software engineering all about trade-offs, and we also have some here. A bit of disclaimer here. In this story, I'm not going to talk on behalf of my company name or the one I used to work for previously. It's my personal experience, which I want to summarize and present here, and also reflect on it a bit. And now we are ready. Let's go and start our journey. And let me introduce Alex. Alex is my friend, but more important, he's also a backend engineer who did a lot of nice things in the past. He built some systems, solved some solutions, complicated challenges. And once he went to Italy and had an enjoyable trip and fall in love with one of the pizza here. And from that day, he started to experiment with recipes, finding the best place, and set up a mission. From that day, he decided everyone in the world should try such a nice pizza worldwide. And how can we accomplish it? So, being a software engineer, he can create some kind of platform. In that case, he created the pizza as a service, a monolith app providing some features like easily onboarding the new product for businesses. Who wants to produce pizza can just go to this platform and make the suggestions here. Also, some common features to utilize like warehousing, delivery analytics, etc. And from another side, he wants to provide the outstanding user experience for the audience, so they can go to the app, website, and do whatever they want and get whatever they want. And in turn, people like the idea a lot, and more businesses start to onboard on this platform, and not only pizza, but other kinds of food. It's become like a Netflix for food streaming. And that sounds great because mission is close to be finished. However, Alex faced a number of challenges. From one side, he has customers who want to see new feature released as soon as possible. They want to process more orders because obviously it just increase the profitability of the company. And they also want to make it fast. So the platform should work fast, the process of onboarding should be fast, everything should go smooth. From another side, he has development team who have to ensure all these requirements. And they want to maintain the level of independency. They want to independently develop, test, and deliver code. They probably want to utilize the best patterns and approach on the market, like event store for some cases. And they mentioned microservices, one of the options to go towards this direction to ensure this independence level. Well, what we do when we don't know a lot about the technology? Go read some books about the domain-driven design, about the microservices, check a couple of reads, maybe have a crash course from zero to hero. And now we are experts in this topic. For sure not, but at least get better what Alex did and came up with the brand new design. Instead of the monolith app, he has a number of well-designed and bounded services. But there is something suspicious here. And I believe you already noticed that all of them still using the same shared database in the middle. And if we go check best practices for data for microservices implementation, or ask your colleagues, or simply just ask ChatGPT, you will see that it's something supposed to be anti-pattern and have to be abandoned at adding costs. And it has its point. However, is it really that bad? And if we can live with that approach, let's take Alex and his team and help them to figure it out. Because there are clearly some benefits from using the shared database. First of all, we have AC transactions, and we can run complicated operations across subdomains and make them atomic. That is good. We still have strong consistency here. Second, it's easy to query and join data because we can utilize the database engine, which is designed to be efficient and provide such kind of operations from the scratch. And finally, we don't have further development efforts. You remember, we still have some features to be released as soon as possible, so we can invest more in the product development instead of this huge refactoring. But benefits go with the drawbacks here. And first of all is coupling. And that's probably already enough to switch approach, because coupling is something we try to avoid when we go from the monolith to the microservices approach. And let's take an example here. Imagine you have users and delivery services reading data from the same user table. And that's fine until one day, delivery service decided to split billing address into the 3 separate fields. It's just easy on their side to process data. So they came up with this idea, make a merge request, push, roll out. And after that, user service got broken because on their side, the code base is still waiting for the old database schema. It's worth mentioning that in production, it's barely going to be a problem, because you have some smoke tests between services and you have some pre-production environment where you have to catch these problems, or maybe have some kind of code review process which doesn't allow you to do such kind of things. However, there is still a necessity to consolidate changes across 2 teams. And if it's just 2, it's fine. Maybe it has 5, 6, 7. It may be even more complicated, and it affects time to market. So we need to figure out that. Second, we actually can have some kind of isolation level even on the shared database level by utilizing the specific schemas. We may say like user schema is for user service, delivery for delivery. We can have some kind of rules, access, etc., and don't allow to read from wrong places. And we can even have some public views to combine the complicated queries and reuse them across services. Still, coupling will be there because these views are constructed from the tables. And if you have some changes on the table level, you also have to update views and do it in a non-breaking way. So, but worth mentioning that ability exists. The second drawback I see is the database being bottleneck here. In a few weeks we have a European Cup in Germany, and I would expect more people who's going to enjoy pizza with friends and see some games. So we may have more traffic on delivery side. And how can we handle it? Okay, let's just add more instances. Now we have a separate service for that. However, when peak days come, we may see problems on other services. And that's probably because there is still same database handling all the requests from all the services. And if we need to ensure the traffic is handled properly, we also need to scale this database because it has its own CPU, memory, network configuration that defines the bandwidth. So yeah, that's something also have to be adjusted. And if we're talking about the vertical scaling, getting more resources to node, possible, but we don't know the exactly load we want to handle. We don't know how many services going to scale, etc. If we're talking about the horizontal scaling and any more instances, that's possible, but also challenging, especially for relational databases. They're supposed to be single node ones. There are solutions here like services, like a persona cluster, or maybe cloud solutions. But yeah, that is something we need to deal with. If you have shared database, it might be hard to evolve in the future if you want to utilize a different data management approach, or just change database type. Maybe you want to go to cloud. Now you're on board AWS or Azure, so you want to go there. But if it's shared and coupled, it might be challenging and takes more time. And yeah, finally, the polyglot persistence. That is something about using different database type by different teams up to the use case. For example, someone wants to work with the event sourcing and they prefer event store. Some of the team has like graph-like data and maybe Neo4j is better fit for them. If they have shared, I don't know, SQL database, they still work with that, but it might be not that convenient and not the best option in the market. Something also worth mentioning. And just to wrap up this part, I believe shared database has its own benefits and they are good, but significant drawbacks such as coupling and bottleneck may drive us to change the decision. And that's what happened with Alex and his team. They decided to embrace the big refactoring and switch approach and having database per service pattern here. Looks good. And they're about to plan work and start next sprint with the splitting. However, the question is, now we don't expose database API across services. How can we get data from different subdomains? Because we have a feature in the backlog that's asking for review cards in the menu item interface. And here, people want to see some data about the menu item. And at least 4 services part of this card. Like we have a user photo, we have review score, we have some details about the menu item itself, like a name and when order was processed. So 4 services combined here to provide this user interface, the data for user interface. Obvious solution here, okay, we don't have database API exposed to public, but what if we do that on the application level and services themselves provide a public API? So in this case, we can say review getting data from all the parts, do the aggregation, prepare the response, and reply to the front end with the suitable data to consume. That's fine. We can even use over the existing technology, like maybe RESTful API or gRPC, maybe have a GraphQL onboarded. But also we need to maintain the level of complexity. For example, we need to take care of configuration, service discovery, because review need to know which services have to be called under the hood. And also fault tolerance experience here. What I should do if some of the services respond with error. Should I make a retry? Should I have a kind of fallback? Should I partially respond to the client or maybe fail the entire request? That is something to figure out. And that may be even more complicated when you're talking about several services do the same. For example, analytics collect data from the same parts and also have to implement all this configuration code here. Well, there's something to think about. And yeah, the first idea, maybe we can have something like service mesh, which encapsulate this infrastructure work, ensure the fault tolerance and configurations here. So we can just run it as a sidecar close to our container and just utilize and reuse the same features. Might be improvement. However, business parts still here. We need to get data and combine them, maybe prepare for the response. So instead, we can reconsider approach and have a API composition pattern here. By introducing the service in the middle, which is responsible for data collection and aggregation, which keeps the configuration complexity and also ensure the same small fault-tolerant experience. And yeah, talking about this orchestration-like approach, I thinking about the GraphQL Apollo Federation as an example. For example, you can have a number of services which expose the GraphQL API to the public as a subgraph. And this subgraph may be onboarded to the Apollo Federation, register inside, and now the router, also part of the federation, analyzing the incoming request, smartly navigate to the proper part to collect all the data, synchronously or asynchronously, depending on the request itself, if there are some dependencies, and provide the combined response to the calling side. Might be an option, because it feels like we maintain the service independence level here. If you have to onboard your one, you just create a service, create a graphical API, and register it in the federation. You don't have to think about schema stitching, because it's sort of working out of the box by federation. And this solution also has good documentation and examples, and also paid subscription, which goes with the support. But yeah, there are also drawbacks here. And first of all, for sure, you need to lock on the graphical dependency. If you don't have it, it may take time to bring it. And I know some people who don't like it, so it might be a problem. You can't fine-tune rotor behavior inside. It's working based on some internal mechanism, and you don't go inside. It's a black box. At least I didn't find a way, and I don't think we should do that. So if you want to make a request fast, yeah, but not much options there. And also, it has its own learning curve. You have to invest time to learn GraphQL, how a federation works, how to set up environment, etc., etc. So if you go in this way, there are some investment in time and skills have to be here as well. So first trade-off. Getting back to composition, now we have a single point responsible for collecting data and providing the best experience for calling services. That also means it's getting the critical point. If it fails, everything fails behind it. Also, we adding extra latency because we have one more extra network call that we expect more time to get data on the front-end side. And also, it's not clear how do we scale downstream services here, because if we handle more traffic on the composition level, we may need to scale downstream services correspondingly. Alternatively, we may think about caching, but it's also complexity where this cache should be on the composition level. Maybe it should be distributed across downstream services, maybe on all the sites, and it's also have to be invalidated. So that's a solution. Also takes time to implement and needs some investments. Yeah, just let's wrap up this part. With the real-time data access, when we're getting them on demand, calling the services, when we have some requests, we kind of have a composition way, which allows the smooth behavior in terms of data aggregation, which keeps the configuration complexity and also ensure the fault tolerance experience there. But yeah, we know that's getting more critical service, which have to be maintained properly. We also increase latency because of the network trip, and we don't know how to scale it efficiently and independently. And the question from Alex, which is actually good. If latency and scalability are big concerns, what can I do about that? For example, he has a kind of customer-face application which should work really fast, and the front end should get the data as soon as possible and provide the smooth and best UX experience for the users. Well, what if we query data from the domain as we already have everything we need? And for that, we can actually bring data in the background by utilizing integration events as a public contracts. Anytime many users or orders have some updates, they put the message into the queue, into the topic, and the subscriber or consumer, in this case, it's a review service, just subscribe on these topics, getting updates, aggregate data somehow, make some calculations, maybe translations, and put into its own memory. In that case, we getting data asynchronously, not on demand, but just in the background. So we kind of eliminate network dependency and don't worry about latency anymore that much. We also can scale this review service independently, because now the downstream service is not called on the real time, and we can just do whatever we want with the review domain itself. And yeah, since we're getting data inside, we can make them ready to be consumed by frontend. We can make the translations of them. We can make them better in terms of efficiency. Worth mentioning that there is a case that the data here is stale, because we don't know when the event is processed. We don't know how many events in the topic to be processed. And we don't know if something went wrong in the middle of the process, because there are many parts like producer, consumer, the topic itself, infrastructure layer. Maybe some data get lost and we don't have them in this database. So they're kind of not synchronized with the source of truth. What Alex also noticed is that setup it feels way more decoupled. Now services know nothing about each other, and they just interact with each other on the topic level by consuming and producing the events as a public contracts. And that's true. However, the events have to be designed carefully. Let's take an example. Imagine menu service has just one topic, universal one, where all the menu item updates published. So every time fields change, we just send the like old new state and provide it for the consumers. Consumers can subscribe on it and do whatever they want. It may feel quite convenient because it's just one topic, not a complicated setup. And also you don't have to change a lot for the new use case. For example, new users have to be onboarded and consume this topic. It already exists, just use it, and that's here. However, this menu item updated schema, very similar to something we have internally for the menu. So it's kind of maybe a copy of the database schema of this item. And we kind of leaking internal implementation details into the public. And when you change the menu item database schema on the menu domain, you may need to provide corresponding changes for menu item updated, meaning that consumers also have to be updated. And now we're getting back to coupling. Despite of using events and no direct dependencies, coupling is here. We need to do non-breaking changes. We need to do it maybe incrementally in a few steps. Probably the better way is having more granular and specific business-oriented events instead of data-oriented. Anytime we have a new menu item name, we just put the new item name event. If promotion is requested, we can send the item promotion event. And if it's out of order, just send the event not available. And from right side, if service interested in this specific update, it can subscribe on it. It doesn't have to listen for all the topics. Also, you may notice that the even contracts, they are very small and barely change. So if it's item ID, it must probably stay the same for a long time. Or it feels more safe and well organized from the decoupling perspective. And when I'm talking about the events and that approach, the change data capture approach came as an example here. Some kind of CDC tool may listen for database updates and provide the transaction log events updates to the broker. Broker may distribute them across the consumers. So in most cases, it's mentioned as the way to fill in data inside warehouses or make some audit tools, probably invalidate cache, but I think it also works for other domain services. But yeah, keep in mind there's still same concerns here in terms of events translations. We don't want to expose the internal implementation data of the specific domain into the public. We want to translate this message into the easy to consume public contract. That's just an example. And no events come for free because you need to have an infrastructure level, which you have to maintain. It's maybe, I don't know, Kafka cluster or maybe some service solution you bought. You have to pay for it. You have to ensure the high-level observability and the error handling of the system, because with asynchronous communications, it's hard to catch the problem and it's hard to react on them. So you need to have some kind of resiliency logic here probably as well. There might be cases there are no real data, real-time data exists, as we covered before. Something went wrong or even not processed yet. So if it's critical for your use case, might not be an option. Yeah, and if you already have a huge amount of data before events are here, you may need to transfer that data into the new domains. And maybe you just scan database once and put all the events from the scratch to reprocess them. Or maybe you can have some, I don't know, migration tool which requests data from the database, transfer and put it to another one. That is possible, but that's a concern you have to take into account. And yeah, after this meeting with Alex and team, it feels like events not easy to use. And I agree, it's definitely increased the overall complexity of the system. But maybe we can have kind of incremental steps and make the easy approach easy to implement. And we actually have an option. Instead of utilizing events, we can have kind of materialization job, which runs when it's configured, gets data from different places, and bring that to our domain. In that case, this materialization job still can use service-to-service calls, I don't know, RESTful API, by getting data, and it can do the data translations before put to the storage. It might be the background task of your service. It might be the cron job, which is running inside Kubernetes, for example. It might be a serverless solution. You can configure delays. You can configure cron schedule. So it's up to you. And in this case, we don't use events, but we still make this modernization job and reviews internal implementation details. So we can scale review independently, and we don't depending on the downstream services on demand, because the process getting happening in the background. And it's also totally fine to combine the approach. Imagine you have a long-running job, which takes 1 hour to process huge amount of data. So you don't want to run it every hour, not to pollute your resources. So maybe you can run it once in 4 hours. And if some of the services already expose events, or just started to expose the events, you can also subscribe on them and just make your data more fresh. So that's totally fine to do this combination if you find it useful. And to wrap this part with async data access, we don't have network travel on demand because we're getting data to our domain from all the places in the background. We can scale independently now because that's the only concern of the specific service now. We don't scale the underlying service, downstream ones. And yeah, we query data within the boundaries. However, we need to pay costs like infrastructure, for example, for events. We increase the system complexity for sure, and there might be possibility to work with the stale data. It might be not up to date. It might be not synchronized for the entire system. It's kind of eventual consistency here. And that's more or less it about the options I wanted to discuss today. And the key point that I noticed when preparing this stuff and talking today is there is no best solution. We have different options, and up to the characteristics, up to the necessities and the use case, it might be better fit or might not be. If something went wrong for one team, it's not necessarily your best solution. And the question from Alex now, okay, we have too many options. We already increased the system complexity. How can I actually choose the right one? What should I do to understand that? And that's a great question, which I also asking myself a lot of times. Let's try to come up with kind of decision-making framework. Because we're not guessing when we create a system design, we rely on the specific characteristics, functional and non-functional requirements. Let's investigate what are the requirements for our system. Let's bring it together. And for every specific use case, we can prioritize. What are the critical characteristics we need to ensure? Let's take an example. We have a request from business owners that they want to see the menu item performance report within an hour, within a week, day, week, month, any time range is possible. And they're getting data from menu, orders, and reviews. So we need to combine data and provide a nice dashboard for the front-end site. And in terms of characteristics, it's critical, so time to implement should be fast. Since the short period is possible for item performance, we prefer real-time data because even like 2-3 missed items may change the entire picture. Yes, and since we don't have a lot of time to implement, we would make the system complexity on the maintainable level. Now let's put all the options together along with the critical characteristics and run the trade-off analysis. About the real-time data, we know that service-to-service calls and API composition, getting data on demand on the fly, so just getting them from the source of true domain, this should be real-time. But might be an issue for integration events and data materialization, because there might be stale data here. So now we can choose between first two and forget about last two options. Time to implement service-to-service calls feels easier because we don't have to introduce a new service. We don't have to do some infrastructure work, the deployment work, etc. So it just feels like less work here. And for the system complexity, we already have some RESTful APIs here. The only thing we need just to call the endpoints and get data here. For API composition, we may need more work and it might be more complicated setup. So we decided to go with the first option. I want to point out that despite we choose this one for this specific use case, it's not necessarily the best solution, because in the time the API composition may be better because we can reuse it across other services. And yeah, that's just better way to organize things in your system, might be a better way. But yeah, running the trade-off analysis here, considering the circumstances and limitations, we decided to go in that way. But there is another example. Now the application users, they want to see the menu item reviews. You do remember this review card which you have previously. Now we're getting back to this Jira ticket. Users want to see some comments about the menu items. And you may notice that exactly same services providing data, menu, orders, and reviews. But now the characteristic may change, because that's a customer-face application which provides data for the front end, and they have high requirements for latency. We may need to scale it because of the peak hours, and also a special request from product owner. That's not a feature which gives us money directly, and that might be experimental, so we can switch the approach. In the future, let's not invest a lot into the infrastructure costs. So those are free. We want to analyze between. And they do the same. Latency is the better for last two events, integration events and data materialization, because we don't have extra network trip. And the same for scalability. We don't have to think about the downstream services scaling. That's the only concern of the specific domain we're going to use for this feature, in that case, reviews. So now we can choose between the last two options. And infrastructure costs feels better for data materialization, because we don't have to onboard Kafka cluster, for example. We don't need to get any cloud solutions for that. So we just create a job or create some background task on the existing service which do the work and provide the data for us. So in that case, we decided to go with the last option. And yeah, you see, we have same data providers, but we have different use cases. And based on these different use cases, we had different characteristics that actually drives our analysis. And yeah, that's just to wrap this decision-making framework. First, we collect the characteristics. Next, we define the use case and filter out the critical ones. They run the performs trade-off analysis, and finally make a decision. I think that works. That works for me, should work for Alex, and I use it not only for business cases, also when I need to choose the specific database option or refactoring or whatever. I can run it, I can see the benefits and the trade-offs, and that actually make the decision more strong and confident, and also helps to get feedback and provide your visibility for your colleagues. And the key takeaways here are the context is important. If something went good for one team, it's not necessarily your best practice. And each single use cases may be evaluated separately and may be specific. So we need to keep this in mind. The second key point is characteristics drives the analysis. We try not to guess about the system design. We try to come up with the meaningful number of requirements and build our solution based on that. And finally, there are trade-offs. There is no silver bullet, no single solution that fits everything and works perfect. Even for monolith and microservices, if you want to go the microservices way, you have to give up on the simplicity over the independency. And yeah, working with microservices brings lots and lots of challenges you have to deal with. And I want to say thank you, everyone, for participating today. It was great not to be alone and describe the idea for Alex and his team. And the more important, now he's ready for his mission to make everyone happy with this nice pizza. Thanks again.
Awesome. Thank you. So there are not many questions, but let's kick off with a question from your personal experience. What would you say was let's phrase it like this, the most difficult part learning? So maybe difficult in the sense that, you know, that you already tried something and maybe it looked good and you went even to production with it, but then something failed. And so that was let's say a hard lesson to be learned, right? Because it wasn't obvious in the beginning.
Yeah, sure. I think there were a number of things like that. I don't recognize exactly ones, but this changing from the monolith to microservices approach, definitely, because I mean, if you start, let's say 8 years ago, you don't have a number of tools already. You don't even know like a best practices. Maybe you don't have such experienced colleagues around you who can help with something. For example, very first approach I've tried with microservices was kind of CRUD oriented. I just make some like CRUD services, put them in network and say that's a microservice. But that's actually not, because no domain boundaries here. It's just kind of separate deployable unit, but it doesn't make it easy in terms of design. So applying domain-driven design is challenging, I guess. And for me personally, because it takes time. It needs you be either domain expert, or you have to have domain experts that helps you. So that's one of the challenges I had.
Okay,
sure.
Great. Then also a question from Maxime: when to choose design patterns?
When to choose design patterns?
Yeah.
That's a great question. I think it's better to choose them before you have already some kind of implementation. And from the past experience, I can share some approach. How can we does it in the previous working company and the current one? We have some kind of proposal, let's say from product owner, we need to do that. So then we start the investigation. What do we need to involve? What kind of integrations we need? We collect all the sites, all the feedback, and organize it as a kind of document with all the things. Now you can check for challenges, check for trade-offs. You can provide the high-level solution to that, collect the feedback from colleagues. If you need to involve something outside, maybe some architecture who could help you, you can also do that. It's ready. So then you can start with implementation. But I would also say it depends on your company, it depends on your use case. If it's really simple and you have no doubts about it, I don't think such a big process required. So if it's a simple solution and you already does it in the past, if it's something which is already used widely in your company and you know for sure it will be in that way, so yeah, just might be like this.
All right, great. Then we have another question from Sidas. Can you tell more about event schema management?
About event schema management, I think that refers to the slides we have about this menu item. Maybe the main point again, to try make this public event contract independent and non-containing any internal implementation details, because you have to change it eventually and you have to make a non-breaking changes, and all your services have to be consolidated later. But yeah, that's apart from that, I think nothing special, just work as usual with the events. Maybe if we talk about some infrastructure, also depending on the company, if you have dedicated team who takes care of your, let's say, Kafka cluster or support the cloud solution, they're always here for you to provide the best practices, and you can ask them. If you implement by yourselves, just try to follow the meaningful approaches here. That's what I would recommend. Also about the events, maybe what I was struggling a bit in the past is distinguish between comments and events when you send these asynchronous things. So yeah, maybe that kind of theory on that regard also can be useful.
All right. We got two more things to wrap it up. The first would be another comment, I guess, from Maxime, who says that service-to-service, API composition, integration events, data materialization need to have experience for teams to choose. I would say, I guess you agree, right? Or what's your take on this?
What's my take on this? What would I choose, you mean?
Yeah, I mean, I guess it's more a comment, right? Need to have experience for teams to choose. So yeah. So if you agree, it's only done via experience, of course, right? There's no.
That's for sure.
Okay. Now another question from Gittis: is it usual to mix these patterns in a single microservice? For instance, having service-to-service calls in one microservice and consume events from another microservice.
I think it depends on the design, but I would say yes. And one of the things why might be also limitations. For example, you like the events approach and you kind of utilize them. But if the service you need to get data from doesn't have events, it doesn't expose anyone, you don't have much options. So maybe you can just use the public API to get data. If they also can handle your load, for example, you get the guys, you said, okay, I need data from your site. Do you have something? They said, we have just a RESTful endpoint. call it. I say, okay, I have like, I don't know, several thousand RPS. Can you handle my load? They say, no, please do it in the background. In that case, I will go with materialization approach. If they say, okay, we already handle a lot of RPS and you several thousand doesn't change it a lot, just call it on demand. Okay, maybe I can do that if I don't care about latency. So yeah, I think it's possible. And also, talking about microservices, it's not necessarily a small, it might be like a self-contained system which do a number of things under the hood. So we may expect a number of integrations, and all these integrations may have different communication approaches.
All right, maybe one final question. Sidas once again to have more clarity on event schema validation. So the specific question is, do you use a schema registry?
I think it's a good question, first of all. And I can't give much details about it because I'm not specifically working around this event infrastructure setup. But yes, I think schema registry is required here. And for example, if you work with Confluent for Kafka, I guess it's called like this, Confluent, they also have this schema registry which provides. So it exists for validation. It makes sure you don't introduce a breaking changes, and it makes sure all the clients who already work with your events, they can continue working on that when you have some changes. So yeah, definitely that is something useful. I think it's not only for events. I think the same work for graphical federation, for example. I also have schema registry, something which is created specifically to keep this video secure.
Yeah, I guess you need to have it, especially, of course, you already talked about testing. So contract-based testing, you want to have that. You want to ensure that this thing keeps on working. So I guess that's the end of the session. A lot of questions here at the end. So thanks everyone for participating. Thanks for the great talk, and everyone, let's have a great conference going from here on. So
yep, thank you so much.
Have a great day, everyone. Bye.
See you.